Not.
You should.
Not.
Here we go. When you look at a graph, and this one's going to be one of the ones that will show you where your calculator runs into problems. Now, sometime this year, I might show you how to do a bunch of stuff on your calculator, but you still need to be able to do some things by hand to fine-tune what your calculator spits out. Okay? First thing you do when you look at this is you might realize it does go through the origin. Never hurts to realize it goes through the origin, 0, 0. But first thing you want to do is take the derivative, find the critical numbers. Now, if you can't take the derivative, it's a bad day. And then you set the derivative equal to 0. You're going to set that derivative equal to 0. That's how you find critical numbers. And you also have to find the points that make it undefined. But here we go. 2/3 x negative 1/3 minus 2/3 x negative 4/3 equals 0. You must be able to factor it. And I know everyone here knows that you factor out 2/3. Don't throw it away. What power of x are you going to factor out? What power of x are you going to factor out?
Negative 1/3.
What?
Negative 4/3.
Yeah, you always factor out the lowest power of x. You always factor out the lowest power of x. Remember earlier in the year we were taking derivatives and I kept stressing that? Always factor out the lowest power of x? Well, there was a reason. Right now.
Why is it negative 4/3?
Because negative 4/3 is the lowest power.
Say like on the derivative, is it not negative 2/3?
Oh. Multiply 1/3 times that.
I mean 2/3.
And then subtract 1 from 1/3.
Exactly.
Yeah.
We subtracted 3/3.
Oh, 2/3. Negative 2/3. Thank you, sir. Wow. I must have already been thinking about something in politics. Okay, that's what happens when you try to understand that stuff. Now, here we go. Once you do that, equals 0. Is everybody okay that you're going to factor out the lowest power? Negative 2/3. This, right here, factor out 2/3, x. Negative 1/3 negative 1/3 minus the negative 2/3 works out to be a positive what? 1/3. And then somebody says you just get minus 1. Yeah. Yeah, you just get minus 1. So, is everybody okay that at 0 you don't get 0? At 0 it's undefined. At x equals 0 it's undefined. Because that's got a negative exponent, right? So that means the 0 wouldn't be here. The 0 would be where? In the denominator. So does everybody understand that 0 is a critical number, not because it makes it equal 0, but because it makes the derivative undefined? Raise your hand if you don't understand that that 0 is making it undefined, and I will write out another step. We're good. Okay. So we'll go over here, put our 0, and we're going to put a vertical line above it because we know at 0 this thing has to be either going straight up or what? Straight down. Then what is the magical number that goes right in here to make this equal 0? What number? 1. Because the cube root of 1 is 1. 1 minus 1 is 0. And above the 1, we're going to put a little horizontal line. So far, so good. Now, we're going to take a number smaller than 0. Pick me a number smaller than 0. Negative 1. When you square that negative 1 right there, it's going to become what kind of 1? Positive. So that's going to equal a positive. Then the cube root of this negative 1 is going to be negative 1, and negative minus another number is going to be negative. Negative times that positive is going to equal what? Negative. For this, we can put an arrow going down. It is decreasing. The f function is what? Decreasing. Okay, yesterday I did f prime there to show we were using the first derivative test. It doesn't matter, but we'll put an f there to show the original function is going down. Now, I have to pick a number where? What's the next number I'm going to pick? 1/2. Okay, 1/2 squared is going to be positive. This is always going to be positive right here. Positive. The cubed root of 1/2, I don't even know what the cubed root of 1/2 is, but I know it's smaller than 1. Okay? Is that okay? So I think you'll get a negative here.
Why is that always positive?
Because you're squaring it.
But what about the negative?
That just means take the reciprocal.
Okay,
Yeah, the negative power just means take the reciprocal, so it won't change the sign of it.
okay.
Okay? Now, somebody says I should have picked the number 1/8, because I know what the cube root of 1/8 is, right? Everybody say it'd been easier if I'd have picked 1/8, because the cube root of 1/8 is 1/2. That would make that negative. 1/8 with this would still be positive, because I'm always what right there? Squaring it. And I get a positive times a negative, so I get a negative. So this thing is going to go through 0, going straight down, and it's going to keep going down. Okay, pick the number. What number are you going to pick next? A number what? Larger than 1. I'm going to pick 8. Why am I picking 8? Because it's easy to do what? Cube root of it. If I put 8 in here, we know it's positive, right? I put 8 in here and I take the cube root of it, and I find out this is what? Positive times a positive is? Positive. Goes up. All right. With just that information, I could go ahead and make a good little sketch. I know right here it's going to be going straight down. And then if you put 1 in here, does everybody agree you can find the y value? What's the y value for 1? X equals 1, the y value is? Negative 1. So over here at 1, negative 1. 1 comma negative 1. And I know at that point it's going to be going horizontal. So if you wanted to, you could probably in your brain realize it's probably going to come in here like this, hit here, come over here, and then do what for the rest of its life? Go what? Up. Yeah, so you could do a rough sketch with a light, just lightly with a pencil, just make a light rough sketch, but you might miss some concavities. Okay? You might have some problems with concavity. So let's chat about concavity. In order to do concavity, I need to do what? I need to take what derivative? I need to take the second derivative. To do that, what I'm going to do is I'm going to go back to this one, and I'm just going to do the second derivative right over here. If I got room. Okay. Negative 1/3 times that is negative 2/9. X to the negative 4/3, because y'all are going to help me not make that mistake. Plus 4/9. X to the negative 5/3. And if they're looking at that on the screen, they probably can't see it. They can zoom in. But anyway, I shouldn't have written it up, crunched up that close anyway. That was bad. You're going to take that and you're going to do what to it? You're going to set it equal to 0. You are not finding critical numbers. You're finding very, very important numbers. All right. Now, 2/9 x negative 4/3 plus 4/9 x negative 5/3 equals 0. Okay, I'm going to factor out a positive 2/9. I don't know. I kind of want to factor out a negative 2/9. That way I'd put the negative sign where? Here, right? But it doesn't matter. But you got to factor out a 2/9. I think everybody sees that. I'm going to factor out a negative 2/9. And that'll leave a 1 here, but it'll leave a what? -2 there. What value of x am I going to factor out?
-5/3.
Negative 5 what? Thirds. Okay, what is that going to make this x right here have a power of?
1/3.
1/3. So what are your important numbers for your second derivative? 0. Makes the second derivative undefined. And what's the next important number? 2 is a good guess, but it's not 2. It's the cube root of some number that makes 2. 8. And this is where, if you did not know how to do this, your calculator is going to mess you up.
Wait, why is it 8?
Okay, what's the cube root of 8?
Why is it plus? Oh, that's what makes it 0. Okay.
Yeah, cube root of 8 is 2, and 2 minus 2 is
0.
0. Now, if you hadn't factored out the negative sign right here, it still would have given you 8, because you'd had to take the cube root, and it still would have given you the same thing. Still would give you 8. Now, we need to know when it's smiling, when it's frowning. We're doing the Mona Lisa test now. All right. Pick a number smaller than 0. -8. -8. If you take a negative number and you raise it to the 5th power, it is still what? Negative. You take the cube root of that negative, it's still what? Negative. Negative times negative makes that what? Positive. But then, if you take the cube root of -8 here, you're going to get what? -2. And that's going to be what? Negative. So when you test, I'm going to put testing. Test. -8. You get a negative. It frowns. So that means it's going to be coming down, but it's got to be frowning. Coming down, frowning. It never turns around and comes back down over here, folks. Because it can't be going up anywhere back here. It's always got to be going what? Down. So it spends all of its time frowning about life. Now, it's got to keep going down. Pick a number between 0 and 1. What number am I going to test?
8.
I'm going to test 1/8. Yes. Okay. Cube root of a positive, 5th power, that's all going to be positive, times a negative, that's going to make that negative. That's going to make that negative. And so the result is going to be what? That it ends up between 0 and 8 doing what the whole time? So it's still going down, and then it smiles. So right here is an inflection point, because it's frowning, and then it starts doing what? Smiling. And then this is kind of, I think, and it's worth noting, let's put 8 in the original and find out what value 8 gives us. Might be neat to know. Put 8 in the original, what do you get? 0. Yeah, you sure do. 8, 0. Now, pick a number bigger than 8 and see if it keeps smiling or if it starts doing what? Frowning. Test a number bigger than 8. 64. Cube root of 64 is 4. That's positive. That's going to be positive. Negative times positive is negative. So after the value of 8, it starts doing what? Frown. It goes up. And folks, it does not go straight up here. And it does not go straight across, and it starts frowning. Now, when it starts frowning, it never goes back down. A lot of people think it's going to frown, it's going to go back down. No, it's just going to always be frowning as it goes up. Inflection point here. Inflection point where else? There. Relative minimum here, which also turns out to be an absolute minimum. This is the lowest it will ever go, right here. That's a relative minimum, and it's a what? Listen to what I'm saying now, though. That is a relative minimum and an absolute. There is no absolute maximum. It goes up forever over there, it goes up forever back here. Yes, ma'am?
So when you asked us to plug 8 back into the original,
Cube root 8 is?
right, but hold on, you got 0, could you have gotten that same thing? Because if you plug 8.
Nope, you've got to plug. If you want a y value, you must plug back in the original.
Okay.
Y values only come from plugging in the original. It's just a coincidence that it happened to be 0 somewhere else.
Okay.
Y values only come from the original. Increasing and decreasing only comes from the first derivative. And concavity only comes from the second derivative. Okay? But it is kind of cool that it, just as it crossed the x-axis, it also changed inflection. But that's not going to always happen. All right. But this is the kind of problem where a student they just use their calculator, they'll just keep it concave up out here. You can't do that. You got to use that second derivative. All right. Now, with that in mind, Mr. Evans could always find one that's kind of nasty for you guys. And notice I'm just skipping the ones like y'all did in Mr. Allgood's class where it's just a polynomial. Fair enough? You know, we're just skipping those. All right. Y equals. Yeah, I'm cheating. I'm using the man's book. Y equals at 5 x to the 2/3. I can't believe it's going to be another one like that. Minus x, oh gosh, x to the 5/3. Can y'all read that? Okay, take the derivative and find the critical numbers. Take the derivative and find the critical numbers. And for those of you that are saying, I'm just going to learn how to do this on a calculator, you're going to have a few problems. I will show you a way to do really good graphs on a calculator, but you actually have to put 2 on the calculator. You have to put the derivative graph on the calculator so it will tell you information that you need. Calculator's not good about telling you everything. And if you punch it in a calculator, wrong, tell you a bunch of bad stuff. Big graphs. Please do not make a graph where they'll fit on a postage stamp. They will not help you. Get stuck, I'm going to write a little bit on the board here, try to help you get through, and you can go and you look at the board if you're getting stuck on something. I'm gonna just throw it up here real fast and let you work and see, and then I'll do a little bit on the board. Checking that in my head because I'm just surprised it worked out so pretty. Then test your numbers. Don't take the second derivative until you have made a test of all the first derivative stuff. That's something the students do, and then they walk up to me and they've got more information than they can process. You find the critical numbers, you find the increasing, decreasing, then you worry about the second derivative. Otherwise, you'll start trying to get the second derivative to do things it doesn't do. Yes, ma'am?
Why do you put those lines above the number?
Okay, 0 made that undefined. That means the graph is going to be vertical at that moment. 2 made it what? Equal 0. That means that you're going to have a horizontal tangent at that moment. What I'm doing is I'm telling myself that at 0 I better have a vertical tangent, and at 2 I better have what kind of tangent? Horizontal. I'm helping, because I know it's not simply increasing or decreasing there. I know that I got vertical or horizontal, and I'm telling myself which one. Does that help?
Yes, okay.
And make your little arrows. Put your little arrows up there when you test it. How many of you are testing it and finding your arrows? You need to have some little arrows when you test. That's right. Put -1 in there to test for your negative number and see what you get. Just remember the cube root of -1 is still what? -1. When I'm testing them for -1, I'm realizing that's going to be a negative when I take the cube root. Positive times a negative times positive.
I don't understand how you do that part. That part confuses me
Okay.
every time.
Take -1.
Mm-hmm.
Okay, you agree that 5/3 is positive.
Mm-hmm.
-1. What's the cube root of -1? -1. Negative. Then 2 minus a -1 is going to be a positive. Positive times negative positive is going to make a negative. What you got to do is you got to know your cube roots pretty fast, okay? And just remember the cube root of a negative, the odd root of a negative is going to be negative. Even if you don't know what the number is, the odd root of a negative is negative. All right? Now when you test 1, the odd root of a positive is still what? Positive. All right? Odd root of a positive is positive, so positive, positive. And we're testing 1, so we still get a what? Positive. Can't test a number bigger than 2 yet. Now we're going to test a number bigger than 2. When I test a number bigger than 2, I'd like to test 8. Why am I testing 8? Because it's easy for me to do what? Take the cube root of it. Although it wouldn't matter, because I still know it's positive. Any positive number, when I take the cube root, is going to be what? Positive. So it's going to be a positive. But then 2 minus 8 is going to be a what? Negative. And when I multiply all those out, I find out how to get a negative. So for all the numbers bigger than 2, okay, here it's going to go up. And then here it's going to start going what? Down. How many people had that? How many people already have those points on their graph? You may already have those on your graph. You got 0, 0, right? And what do you get when you put 2 in there? Oh no, Mr. Evans, it's not going to be a pretty number. Oh, we'll put 2 in there.
You get 0.
You think you get 0 when you put 2 in there?
It would be 2 minus 2.
Yeah, but that's not the original. Got to put the 2 in the original. That's 4 to the 1/3. I'm trying to think of anything you can do to make this prettier. You can make it 5, 2 to the 2/3 minus 2 times 2 to the 2/3. Because 2 to the 5/3 is 2 to the 3/3 times 2 to the 2/3, right? Why would I do that? That way I got 2 to the 2/3 here and I got what? 2 to the 2/3 there. Make it pretty.
Can you factor that out?
Oh yeah, so I've got 2 to the 2/3 times 5 minus 2. See, because I got 5 of them here and I got minus 2 of them there, so I got really how many of them? 3. You didn't even need that step. There you go. And so that's what it simplifies to. Now, if you were in a college classroom and you wrote that, your professor would feel happy. If you had a perfect paper, he'd probably mark off 5 points. If you'd already had an F on the test, he probably wouldn't mark anything off because, you know, at least you knew that. But yeah, the key to taking care of this is realizing that's 2 to the 3/3 times 2 to the 2/3. That step's really not needed. And then that's 5, 2 to the 2/3 minus 2, 2 to the 2/3. And then when you subtract them, you get what? 3 times what? 2 to the 2/3. So you're at 2, and you're up at 3 times 2 to the 2/3. Somebody said, I put the cube root of 4. Yeah, you could. And that is your value. Now, it's got to come down to here, then go up to here, and then come what? Back what? Down. You already know that when it comes down here, it's going to be going straight down, right?